Hello friends, welcome to Math Practice. Today we are going to discuss polynomials and different types of examples in it. So watch the video till the end and subscribe to Math Practice. First, some definitions. Polynomials are mathematical expressions made up of variables and constants by using arithmetic operations like addition, subtraction and multiplication. So the general or standard form of a polynomial is if x is a variable and a0, a1 up to an are constants, then f of x is equal to an x raised to n plus an minus 1 x raised to n minus 1 up till a1x plus a0 is the standard form of the polynomial in variable x. For example, I can say 2x square plus 3x minus 8 is a polynomial. 3x plus 2 is a polynomial. Only number 5 can also be said as a polynomial. The exponents of the variable in any polynomial have to be non-negative integer. That means they have to be a whole number 0, 1, 2, 3 and so on. The exponents means the power. For example, the coefficient of x square in this polynomial pi by 6 x square plus 3x minus 4 is pi by 6. But in x cube minus 6x plus 5 it is 0 because there is no term of x square. Now, a polynomial expression should not have any square roots of variables, any fractional or negative powers on variables, and no variable should be there in the denominator of any fractions. Now, based on this, we will see some examples. Let us see some examples. Check whether the following are polynomials or not. First one, fx is equal to 5x square plus 8. Yes, it is a polynomial. Second one, fx is equal to 8 upon x square plus 5x, or it can be written as 8 into x raised to minus 2 plus 5x. It is not a polynomial because the power of x is minus 2 and the power of x can only be 0, 1, 2, 3. It can be a whole number only. It cannot be a negative integer. So, it is not a polynomial. Third one, fx is equal to 2 into root of 2x plus 3. Again, this is not a polynomial because root of 2x means root 2 into root x. Root x means the power of x will become half. It is not permitted. Next one, fx is equal to x plus 1 upon x plus 5. Again, this is not a polynomial because x cannot be in a fraction in the denominator. So, it is not a polynomial. Next one, fx is equal to only number 5. Yes, it can be said a polynomial because here the power of x is 0. X raised to 0 is 1. So, it is 5 into x raised to 0. So, it is a polynomial. Next one, fx is equal to x square minus x upon 2. It is permitted because the power of x in the second term is 1. But the coefficient is half. That is no problem. So, it is a polynomial. Fx is equal to 0. Yes, it is again a polynomial and it is a special type of polynomial called the 0 polynomial because 0 means 0 into you can write anything x raised to 1, 2, 3 anything. So, it is a 0 polynomial. Next one, f of xy is equal to x square plus y square minus 2xy. It is basically not a polynomial in one variable but you can definitely have it as a polynomial in two variables. Now, polynomial can be classified according to three criteria. First one is the number of variables, second one degree and third one according to the number of terms. Again, let us see some definitions. First of all, what is the degree of a polynomial? The highest or greatest exponent of the variable in a polynomial is known as the degree of the polynomial. For example, a polynomial of degree 1 can be fx is equal to x minus 2. Why? Because here the degree or the power of x is 1. So, it is a linear polynomial. Suppose if you have fx is equal to 2x square plus 3x minus 8, the polynomial is of degree 2 because the highest power of x in it is 2. Or it can also be said as a quadratic polynomial. Fx is equal to x cube minus 2x plus 4. It is a cubic polynomial of degree 3. Polynomial fx is equal to 5 into x raised to 4 plus 8 has a degree equal to 4, or it is also said as a biquadratic polynomial and so on. You can have any polynomial degree. For example, x plus 5x cube minus 6. It will be a cubic polynomial. Why? Because you just have to see the highest degree. A polynomial of degree 0 is a constant polynomial. As I said, fx is equal to suppose minus 5. It can be written as minus 5 into x raised to 0. So the degree is 0. Fx is equal to 0 is the 0 polynomial and its degree is not defined because 0 can be written as 0 into x raised to 0, x raised to 1, x raised to 2, anything. To calculate the degree in a polynomial with more than one variable, add the powers of all the variables in a term. For example, the degree of the polynomial x square plus 8y square plus 3x square y is 3. Why? Because the third term has 2 of power of x and 1 of y. So total power is 3. So the highest power is 3. Now the classification based on number of variables and the number of terms. Polynomial can be of any number of variables. For example, x square plus 8y square minus 4xyz. It is a polynomial in 3 variables. Now according to the number of terms also it can be classified. Monomial is a type of polynomial with a single term. Only one term is there. For example, just x, just minus 5, say 6xy square. Any polynomial having just one term. A binomial is a type of polynomial that has two terms. For example, x square plus 5, 3x cube plus 5x square and so on. A trinomial is a type of polynomial that has three terms. For example, 9x cube plus 8x square minus 5, x plus y plus z, 3x plus y minus 5. All these are having three terms. Example of binomial of degree 30. Suppose you need to give it. So, its highest degree should be 13. 5x raised to 13 minus x cube. This can be the example. You can write any example but provided the highest degree of x is 13. Example of monomial of degree 100. Monomial means it should have only one term and the highest degree should be of 100. So you can write it as minus 5y raised to 100. Next, value of a polynomial. The value of a polynomial fx at x is equal to some number alpha is obtained by substituting x is equal to alpha in the given polynomial and it is denoted by f of alpha. For example, find p of 0, p of 1 and p of 2 for each of the given polynomials. First one, suppose the polynomial is x minus 1 into x plus 1. So to find p of 0, just put x is equal to 0 in it. So the answer is minus 1 into plus 1, which is minus 1. For p of 1, put x is equal to 1. So putting x is equal to 1, we get p of 1 as 0. For p of 2, put x is equal to 2. So 2 minus 1 into 2 plus 1, which is 3. Second example, let p of t is equal to minus 5t cube plus half t square plus 5. For here, if you put t is equal to 0, you get 5. If you put t is equal to 1, p of 1 will give you half. If you put t is equal to 2 in the given polynomial, you will get p of 2 equal to minus 33. Next important definition, zeros or roots of a polynomial. The roots or zeros of polynomial are the real values of the variable for which the value of the polynomial would be 0. If any two real numbers, say alpha and beta, are zeros of a polynomial px, then p of alpha will be 0 and p of beta will be 0. Correct? That means when you put the value alpha or say beta and if you get the value of the polynomial as 0, then that alpha or beta will be the root. For example, for the polynomial px is equal to x square minus 2x plus 1, if I put x is equal to 1, I get p of 1 as 0. So I can say that 1 is a 0 or a root of the given polynomial. This will also mean that x minus 1 will be a factor of px. Okay. Finding the roots of polynomial fx means basically solving the equation fx is equal to 0. Another important result, an nth degree polynomial can have at most n real roots. Means, for example, in the above polynomial x square minus 2x plus 1, since the degree is 2, it can have at most 2 real roots. Basically, to solve a polynomial equation, we can do it either by factorization, we have seen factorization, or by graphical method or by trial and error methods. A non-zero constant polynomial has no zero. Why? Because suppose if I say the polynomial is 5, for no value of x it will be equal to 0. So it has no 0. And every real number is a 0 of the 0 polynomial. That is also very obvious. So remember, first thing, a 0 of a polynomial need not be 0. We have just seen 0 means it is a root and it can be any value. Second one, 0 may be a 0 of a polynomial. So this statement is also true because you can sometimes have the 0 of a polynomial as the value 0. Every linear polynomial has one and only one 0. Just now we have seen that for an nth degree polynomial it can have at max n real roots. So linear means degree 1. So it can have one and only one 0. A polynomial can have more than one 0. This is also obvious because if the degree of the polynomial is more than 1, it can have more than one zeros. Example, if x is equal to 0 and x is equal to minus 1 are roots of the polynomial fx is equal to 2x cube minus 3x square plus ax plus b, find the value of a and b. Roots means when you put that value, the polynomial will have the value 0. So f of 0 is 0 and f of minus 1 will also be 0 because they are the roots. So just put x is equal to 0. So you will get over here f of 0 as b and that is given to be equal to 0. When you put x is equal to minus 1, the equation is minus 2 minus 3 minus a plus b, and that it is, since it is a 0, the value will be equal to 0. So solving it, we get a minus b is equal to minus 5. B is equal to 0, a minus b is minus 5. So putting the value of b as 0, we get a as minus 5. Hence the unknown values a and b are a is equal to minus 5 and b is equal to 0. Now what is the division rule? We know that for simple numbers, if I write 12 is equal to 6 into 2 plus 0, here the remainder is 0, 6 is a factor of 12, or in other words you can also say 12 is a multiple of 6. So in general we have dividend is equal to divisor into quotient plus the remainder. The same holds for the polynomial. In general, if px and gx are two polynomials such that the degree of px is greater than or equal to degree of gx and gx is not equal to 0. Why? Because we are dividing by gx. Then we can find the polynomials qx, which is a quotient polynomial, rx, which is a remainder polynomial, such that px is equal to gx into qx plus rx. Here rx is equal to 0 or degree of rx will be less than degree of gx. So either the remainder is 0 or its degree is less than that of the given polynomial gx. Here we say that px is divided by gx gives qx as quotient and rx as the remainder. Now the remainder theorem. The statement of the remainder theorem. Let px be any polynomial of degree greater than or equal to 1 and let a be any real number. If px is divided by a linear polynomial x minus a, then the remainder is p of a. Let us try to see the proof. Here px is any polynomial with degree greater than or equal to 1. Suppose that px is divided by x minus a, means it is divided by a linear polynomial x minus a. The quotient is qx and the remainder is rx. So we have the equation px is equal to x minus a into qx plus rx. Now since the degree of x minus a is 1, it is linear, so degree is 1 and the degree of rx is less than the degree of x minus a. The only possible value is degree of rx will be equal to 0. This means that rx is a constant. Its degree is 0 means rx is a constant. So now we can say it is sum r. So for every value of x, r of x will be equal to r because it is a constant. It does not depend on x. Therefore, px is equal to x minus a into qx plus r. Now, in particular, if I put x is equal to a in that, the equation gives us p of a is equal to a minus a into q of a plus r, which is equal to r. Hence, we can say that over here x minus a is a linear polynomial and if px is divided by x minus a, the remainder will be equal to p of a. R is the remainder and that is equal to p of a. Now similarly the factor theorem. Factor theorem, if px is a polynomial of degree n greater than 1 and a is any real number, then two things, if p of a is 0, then x minus a will be a factor of px. And second thing, if x minus a is a factor of px, then p of a is equal to 0. So converse also holds. It is very simple. We have just seen the remainder theorem. By remainder theorem, p of x is equal to x minus a into qx plus P of A. Remainder was P of A. So now if P of A is 0, we know that Px is equal to x minus A into Qx, which shows that x minus A is a factor of Px. Now second thing, since it is given that x minus A is a factor of Px, Px is equal to x minus A into some Gx. Now in this case, P of A will be equal to A minus into G of A, which is equal to 0. So we have also got the second part. If x minus A is a factor, then P of A will be equal to 0. We'll see some examples based on this. First example. Find the remainder when x cube plus 3x square plus 3x plus 1 is divided by, in the first case, it is divided by x plus pi. X plus pi, pi is a constant, you know that. So you are dividing by a linear factor x plus pi. That means just now we have seen if x plus pi is a factor, then x should be equal to minus pi. How do you get that? Just equate it to 0. So x is minus pi. So putting p of minus pi, we get minus pi cube plus 3 pi square minus 3 pi plus 1. So that will be the remainder. Second case, suppose if it is divided by 5 plus 2x. Again over here, if you put it equal to 0, x will be equal to minus 5 by 2. So p of minus 5 by 2 will be the remainder. Putting all the values, means putting the value of x as minus 5 by 2, you get it equal to minus 27 by 8, which will be the remainder. Next example. Check whether 7 plus 3x is a factor of 3x cube plus 7x. Now, if it is a factor, what will you get? When you put its value, the value will be of the polynomial will be equal to 0. So now let us try to put the value. 7 plus 3x is a factor, then x will be equal to minus 7 by 3. So putting putting x is equal to minus 7 by 3, we get p of minus 7 by 3 equal to 196 by 9. Obviously this is not 0. So we can say that 7 plus 3x is not a factor of 3x cube plus 7x. If it had been equal to 0, it would have been a factor. Next example. Factorize 9z cube minus 27z square minus 100z plus 300 if it is given that 3z plus 10 is a factor of it. Now in this type of examples, one of the factor is given and you need to find the other factors. We know that since the degree of the polynomial is 3, it can have at most 3 factors. So now if one factor is given, the general technique is by long division method, you divide by that factor and try to obtain the next factor, other factor. So by long division method, when 9z cube minus 27z square minus 100z plus 300 is divided by 3z plus 10, let us see the steps of division. First step, from 3z you need to obtain 9z cube. So you need to multiply by 3z square. So multiplying 3z plus 10 by 3z square, you get it 9z cube plus 30z square. Subtracting it, you get it minus 57z square minus 100z, you bring it down. Again over here, from 3z you need to get minus 57z square. So you need to multiply by minus 19. So multiplying by minus 19z, you get it equal to 3z plus 10 into minus 19z means minus 57z square minus 190z. Subtracting it means you just have to reverse the sign. You get it equal to 90z, bring the 300 down. So 90z plus 300. Again to get 90z from 3z, you need to multiply by 30. So 3z plus 10 into 30 will give you 90z plus 300. Hence the remainder will become 0. So we can say that the other factor is 3z square minus 19z plus 30. So now our polynomial is equal to first factor 3z plus 10 into second factor 3z square minus 19z plus 30. Now to get the two factors from the other factor, you can just use our factorization technique. 30 into 3, you can write it as 10 into 9. So by factorization, you get the three factors 3z plus 10, 3z minus 10 and z minus 3. Now you can directly also do it by factorization method if nothing is given regarding any of the factors. In that case, just you can use the factorization technique. First we have grouped the similar type of terms. So we get that equal to z minus 3 into 9z square minus 100. 9z square minus 100, a square minus b square, a minus b into a plus b. In this case also you get the same answer. Next different type of example. Factorize using the factor theorem. X cube minus 6x square plus 11x minus 6. Now remember one result which will be useful. If fx is a polynomial with integral coefficients and leading coefficient is 1, then any integer root of fx is a factor of the constant term. This means that fx is your polynomial with all the coefficient as integers. The leading coefficient means the coefficient of the highest degree, that is 1, which is the case over here. Then any integer root of fx is a factor of the constant term. What is the constant term over here? Minus 6. So here if you want to apply the trial and error method, then it is easy to know that since minus 6 has factors plus or minus 1, plus or minus 2, or plus or minus 3, you can put those values and try to check whether they are factors or not. Now see over here, if they are factors, you know that putting that value in the polynomial will give you the value of the polynomial as 0. Now if I put x is equal to 1, f of 1 is 0. So here x minus 1 will be a factor. Similarly, if you put 2 and 3, then you will get f of 2 as 0 and f of 3 is also 0. So x minus 2 and x minus 3 will also be factors. Now little bit you can do it looking at the polynomial also over here. Here it is very clear that if I put any of the negative values, no need to check for that, because if I put negative values, all the values in the polynomial will be negative. So it cannot be equal to 0. So possibilities are plus 1, plus 2, plus 3, and putting those values we are getting all the 3 equal to 0. So x minus 1, x minus 2 and x minus 3 are factors. Now they are factors, we know that, but what is the other constant which it can be multiplied by? To check for this, suppose fx over here is a polynomial of degree 3, so we know it can have at most 3 factors. So fx is equal to some constant k into x minus 1 into x minus 2 into x minus 3. This implies that our x cube minus 6x square plus 11x minus 6 is k into x minus 1, x minus 2, x minus 3. The technique is you put 0 on both the sides. So what will you get? You will get the value of k. Putting 0 on both the sides, you get minus 6 is equal to minus 6k, which gives the value of k is equal to 1. So now we know that k is equal to 1. So x cube minus 6x square plus 11x minus 6 is equal to x minus 1 into x minus 2 into x minus 3. Next example. Factorize 4x cube plus 20x square plus 33x plus 18 if it is given that 2x plus 3 is a factor of it. So again over here, first, since one of the factor is given, we can use the long division method. So 4x cube plus 20x square plus 33x plus 18 when divided by 2x plus 3, you can see first term from 2x you want 4x cube. So multiply by 2x square. So you get 14x square, bring the other terms down, plus 33x plus 18. Now from 2x you want 14x square. So you will multiply by 7x. The remainder would be after subtracting 12x plus 18. Now from 2x you need 12x, so multiply by 6. So you get the remainder as 0. Hence the other factor is 2x square plus 7x plus 6. So the polynomial is equal to 2x plus 3 into 2x square plus 7x plus 6. Now you can use our simple factorization technique to get the two factors. So 6 into 2 can be written as 4 into 3. Simplifying it, we get the factors as 2x plus 3, 2x plus 3 again, and x plus 2. So it can also be written as 2x plus 3 square into x plus 2. Now some assignment examples. First one. Factorize using the factor theorem 2x cube plus x square minus 2x minus 1. Answer is x minus 1 into x plus 1 into 2x plus 1. Second one, factorize x cube plus 13x square plus 32x plus 20 if it is given that x plus 2 is a factor of it. So first use long division method and obtain the other factor and then use the factorization technique. So your answer is x plus 2 into x plus 1 into x plus 10. If the polynomial is ax cube plus 4x square plus 3x minus 4 and x cube minus 4x plus a leave the same remainder when divided by x minus 3, find the value of a. So putting x is equal to 3 and equating the polynomials, you get a as minus 1. Next one, if 3x minus 1 raised to 7 is equal to a7x raised to 7 plus a6x raised to 6 up till a1x plus a0, then find the value of a7 plus a6 up till a1 plus a0. Now over here, since you just need the sum of the constants, means x value is 1. So just put the value of x as 1. So you will get the answer as 128. Next one, if x raised to 51 plus 51 is divided by x plus 1, what will be the remainder? Simple fill in the blank type of question. Since you are dividing by x plus 1, putting x as minus 1, you will be getting the answer as 50. Hope the topic of polynomials is clear. Please like and share the video and subscribe to Math Practice for many such videos. Thank you.